All right, so bell work number 8, find the volume of these figures. We are not really going to have to worry too much about these right now. So we said this is a volume of a pyramid. Volume of a pyramid is 1/3 times capital B, that's the area of the base, whatever that base figure is, times your perpendicular height. Okay? So 1/3 times, we already said, what is the shape of my base? Taryn, what's the shape of my base? Do you remember? Yeah, rectangle. Now rectangle, area of a rectangle is length times width. So my length is 7. My width is 5 for the base. And height. Well, the only height we have right now is just 3. I need to check, and it doesn't really say, but does that seem or appear to be a perpendicular height or a slant height? Perpendicular, yeah. So that is the height we are going to use. So times 3. So now we can just multiply all of these together. If you wanted to, you could put on your calculator 1 divided by 3 times 7 times 5 times 3. But we know 1/3 and 3/1 are reciprocals, meaning they are kind of like opposites and they're going to cancel out. If you take 1/3 times 3/1, that simplifies to 1. So now I'm left with 7 times 5, which is 35 in centimeters cubed, because we're talking about volume. Okay? Any questions about that? That first one? Okay. Let's go to the second one. Good morning, Micah. Thank you. All right, second one. We said this is a triangular prism. Triangular prism. All right. So, triangular prism. Anytime you have a prism and you look on your little half sheet, it's going to be volume is equal to the area of the base times the height. Now, we already said these are my bases, okay? So I need to find the area of a triangle. All right, so this is kind of a weird because it's all blackened out and it's hard to write. So area of a triangle is 1/2 times the base of the triangle times the height of the triangle. Okay, I'm going to put this over here now. So volume is 1/2 times, I'm rewriting it, base of the triangle times the height of the triangle times the height of the prism. Okay? So this was my base. This is all my base, which happens to be a triangle, times the height of the prism. So now let's substitute in 1/2. What is the base of my triangle? Like the bottom part of the triangle, only looking at the triangle. What is it? What's the base of my triangle?
Like the measurement of it?
Yeah.
3 times 3.5.
No, just the base. Like if I had a triangle and I was saying 1/2 base times height, the base is what's on the bottom. So in this case, the base of my triangle is 3. Okay? Just the base of that single triangle times the height Well, my height should be right here. Do we have this height? No. So what are we going to use to find it? Because I have a right triangle right here. Pythagorean theorem. Okay. Let's see if I can make this go down. So Pythagorean theorem says a squared plus b squared equals c squared. A and B are your legs. So I'm going to make that A, make this B. This is going to be my C. Now, the fact that they are showing us that these two sides are the same means that this height coming down the center is going to split the opposite side in half. So what is half of 3? 1.5, yeah. So that side's 1.5 and this side is 1.5. So my A is going to be 1.5 squared plus B, I don't know what B is, so I'm just going to leave that as B. And C is 3.5 squared. So 1.5 squared is 2.25, I believe, plus B squared equals 3.5 squared, Jeremiah, which is 12.25. All right, I'm trying to solve for B. Let's subtract 2.25 from both sides. Those cancel out. B squared is equal to 10, but I don't want B squared. So I take the square root, take the square root. B is equal to, I'm going to leave it as the square root of 10. You could change it to a decimal. Can somebody tell me what is the square root of 10? No, you have to do it on a calculator. It's not even. Somebody, please take the square root of 10. Wow, guys, come on.
The square root of 10 is 316.
3.16?
Yeah.
Okay.
Rounding that up, I don't know.
You could say 3.16. I'm going to leave it as square root of 10. So that is my B for the Pythagorean theorem, which actually is my H, my height of the triangle. So I'm going to leave it, like I said, as square root of 10 here. Times, what is the height of my prism? The height of my prism is the distance from one base to the other. So the height of my prism here is 10. Okay? All right, so now we've got all of our numbers. We should be able to multiply them all together. I'm going to do a little bit of simplifying. I'm going to say, what is half of 10? And that's going to be 5. So that takes care of the half of 10. Times 3, which is right there, times the square root of 10. So my final answer is 15 times the square root of 10. And they don't have anything, so I'm going to say units cubed. Now, if you multiply that times the square root of 10, and you don't like leaving it in square root form, I want to say, I did this earlier. I know I did. It is 47.4 units cubed. Okay? So I would take either one of those. Either one of those. So triangular prism here, we needed to use Pythagorean theorem to find the length of the height for that area of the triangle, and then we had to substitute that in. Okay? Any questions on those two? All right, so let's go to page 30 or 29. I'm not sure where it's at on yours. It's cut off on mine. We are talking about volume of cylinders to start with. Volume of cylinders. It's either 29 or 30. Okay. Is it 30? Okay. So page 30.
Actually, well, it starts from like the bottom.
Okay, page 29. We'll get there. How did this get on the bottom? That's weird. All right. So here we go. 6-7. Volume of cylinders, cones, and spheres. Oh my. Lions and tigers and bears. Oh my. Cylinders, cones, and spheres. Oh my. Here we go. So, volume of a cylinder. First of all, is a cylinder... Joellis, can you get your head up, please? Bjorn, eyes up here. Kevin, eyes up here. Everyone! Don't make me do a song and dance.
Oh, God.
I know, right? Is a cylinder a prism of sorts?
Yeah.
Yes, because it has two bases. So, take a look at this. They say volume of a cylinder is, come on, base, area of the base times the height. And when the area of your base is a circle, and we know what the area of a circle is, volume of a cylinder becomes base times height. The base is a circle. It becomes pi r squared times the height of that cylinder. Okay, so that is the big fluffy formula that you need to try to recall. Pi r squared times the height. All cylinders, if they are right cylinders, meaning the sides go straight up, is area of the base times the height. And again, because that base is a circle, area of a circle is pi r squared times the height. All right, so let's go right now to the next page, page 30, and put some numbers to use. Yes?
What's the difference between volume and area?
Volume is three-dimensional.
And its area is two-dimensional?
Yes. Volume is like how many, even though this isn't a perfect cube, how many cubes would fit in this three-dimensional figure. Whereas surface area is how many squares, if you're talking about surface area, make up the wrapping paper that goes around it. Okay? So it's two-dimensional versus three-dimensional. Good question. All right, Postal Service. Andrew wants to mail his brother a collection of antique marbles. He needs to calculate the volume of a mail tube before he buys it to ensure it will hold all of the marbles. Find the volume of the mail tube to the nearest tenth. The nearest tenth, okay? So, what shape is this? It is a cylinder. So we are finding the volume of a cylinder. We know it is a prism of sorts, so it's area of the base times the height. So it is pi r squared times the height. And the height is the distance between the two bases. So we are going to say pi times my radius. Now, from this picture, it wasn't absolutely clear to me what the radius was. As you look at that, it doesn't really say, does it? Do you think that, all right, so looking at the picture, would you say the radius is 1.25 or would you say the diameter is 1.25? You think it's the diameter? Okay. That's now looking at it, I think I see that too, but I put it down as the radius. So, you know what? We're going to make it radius because that's going to make it easier. So just put in front of it R equals. We're saying that is the radius because it's not really clear. Okay? It's not very clear. So radius is 1.25 squared. Okay, here's the area of my circle. Here's my base. Here's my other base up here. Times what is the height? The height is the distance between the two bases. So what is my height? 10. Yeah. There's my height times 10. So grab a calculator. Pi times 1.25. Square that times 10. What do you get? Jewels? Put the phone away. Do you have a calculator?
49 point, wait, 49.1.
Yes. We get 49.08. They went to the nearest tenths place. The 0 is in the tenths place now. Look next door. So it is 49.1 inches, what? Cubed. Because we're finding volume, and that is 3-dimensional. What questions do you have about that one? Okay, let's go down and do the check. We're going to do the one on the right, which is this cylinder over here. Right here. X marks the spot. Okay. Right here, I have a base. Right here, I have a base. So that makes it a prism of sorts. Volume equals area of the base times the height. My base is in the shape of what? If we're talking about a cylinder? A circle, right? So pi r squared times height. Pi. What is my radius of the circle on the bases? Who haven't I talked to? Desiree, what is the radius of my circle? Excellent. It is not 14. 14 is the diameter. Radius is going to be half of that, which is 7. So I'm going to say 7 squared times what is the height? What is the distance in between those two bases? Ranisha, what is the distance between the two bases? Right here. What is it? You can say it. You can say it. What is it? Right over to the right here.
13.
Yeah, 13. Your height of that cylinder is 13. So grab your handy dandy calculators. Pi times 7 squared times 13. Who's got it? Who's got it? Who's got an answer for me? Pi times 7 squared times 13. So my volume is
2001.19.
that is correct. And let's take it to the tenths place again. The 1 is in the tenths place. I look next door. I see it is 9. That's over 5. So I have to go up. So volume is 2001.2 inches cubed. Any question on how to find the volume of a cylinder? Volume of a soup can? Volume of a Pringles can? All right, let's go to the next page. Next page. Okay, so this is another one of Cavalier's principles. This is nice to know, not vital. But if you have a pyramid and prism, they have the same base area. Okay, so they're saying if this has a base, let's say, I don't know, 24 inches squared, and this base is 24 inches squared, and if they both have the same height, let's say that's a 10, and this is a 10, then they're going to have the same volume. Well, we learned yesterday, you might not remember this, but we learned that volume of a pyramid is 1/3 times the base times the perpendicular height. If these two are going to be the same, that means a cone is also going to be 1/3 times the area of the base times the height. Okay? So jump down here a little bit. Words, the volume of a cone. So volume of a cone, we're just writing it bigger, is 1/3 times the area of the base times your height. And if you're talking about a cone, its base is a circle. So 1/3 times pi r squared. Right here. I wanted that in red. Right here. That is going to be the area, not the area, the volume of my cone. Okay. So let's do example 3. Let's use that formula with some actual numbers. Volume equals 1/3 times the area of the base times the perpendicular height. 1/3 times my base, which is a circle, is pi radius squared. The radius here is 2. Whoops. 2 is my radius. 2 squared times the height. They only give me this height. Is this a perpendicular height? Yes, it is. It's got the little right angle thing there. So that's times 8. So on your calculators, everybody, 1 divided by 3 times pi. Let me do this better. 1 divided by 3 times pi times 2, and then you do the x squared button, times 8. If you do all that on the calculator, what are we going to get? Very good. 33.51. If we round it to the 10th place, volume is 33.5 inches cubed. 33.5 inches cubed. What questions do you have about that? Volume, actually, finding volume of three-dimensional objects is easier, I think, than surface area. Okay. All right, let's go to the next page, 32. I'm going to do one more example, and then we'll call it a day. Let's call it Wednesday. I gotta laugh. Don't encourage her, man. Oh, and these are both pretty much the same. All right, so let's do the first one. I'm going to do this one right here. Volume of a cone. Volume of a cone is 1/3 pi r squared h. So 1 divided by 3 times pi times radius. What is my radius? Kevin, what is my radius on that first cone? That is correct. So times 3 squared times my height. What is my perpendicular height? Jason, what's my perpendicular height on that first problem? Times 4. So in your calculators, 1 divided by 3 times pi times 3 squared times 4. Guys, come on. You need to hang in there. Need somebody. Do all those calculations. Put it in your calculator. Tell me what you get. That is correct. Round it to the nearest tenths place. That is 5 or more, so it is 37.7 centimeters cubed. That is the volume. All right. So, last homework from this section. I am going to do, which one did I think I should do? I think I'm going to do the last one with you because that is the most difficult. So this is 6, 7. The homework is going to be doing the front. There's only 4 problems, and we're going to do the last one together. Okay. And it's still recording, so that's good. Live and there. 6, 7. Here we go. Okay, gonna help you with the last problem. Ooh, is that the last problem? Oh. Okay, that's weird. Number 10, automobile. Don uses a funnel to pour oil into his car engine. All right, first of all, I would, if I were you, hopefully maybe you know what a funnel is. If you're putting oil in, kind of looks like this. And then usually there's something like that. It's usually a little bit longer. So the funnel has a radius of 6 centimeters. Radius. Where does a radius go? From what to what? From where to where in a circle? Bless you. It's going to go towards the top. It's going to go from the center out to the edge, right? So this is a radius of 6 centimeters and a slant height of 10. Well, bless you. A slant height of 10 centimeters. So this is why it is helpful to draw a picture. Okay? Very helpful. How much oil to the nearest cubic centimeter will the funnel hold? Well, if we're looking at this general funnel shape, what shape is that we just talked about? A cone. Yeah, there's a circle at the top, but we're talking about volume, so this is volume of a cone. Volume of a cone is 1/3 times the area of the base times the height. Perpendicular height. So that's 1/3. Area of my base is a circle, which is pi r squared, times the height, and it has to be the perpendicular height. So 1/3 pi radius, we said the radius is 6 squared times my height. Do I have a perpendicular height? Survey says no. So we get to use our favorite theorem, Pythagorean theorem, over here, somewhere else, wherever. Pythagorean theorem, which says, because I'm making a upside down right triangle here, a squared plus b squared equals c squared. So my a, I'm going to make 6 my a. This is going to be my b. C is always the side that is across from the 90-degree angle. C is always the largest side of a right triangle. Yeah.
Is that cube, CK?
Circle.
Oh, that's right.
So 6 squared plus b squared equals 10 squared. 6 squared is 36 plus b squared equals 100. Subtract 36 from both sides. And we get b squared equals 64. I do not want b squared. I want b. Take the square root. Take the square root. B is equal to 8. So the height of this funnel is going to be 8. All right, so putting that in a calculator. 1 divided by 3 times the pi button times 6. And then we press the x squared button times 8. What are we going to get for an answer? Anybody got it? That's a lot, I know. Should be 301.5. It says to the nearest cubic centimeter. That means to the nearest whole centimeter. So this is my whole centimeter. I look next door. So I need to take that up to 302 centimeters cubed. 302 centimeters cubed. What questions do you have about that? Do I have to use Pythagorean theorem every time for every kind of problem? No, only when they don't give you the perpendicular height. If they give you a slant height and a radius, you might have to find that perpendicular height. Okay? All right. So the rest of your homework is to do the first 3 problems on the front. On the front, okay? You got cylinders and you got another cone in the 3rd problem on the front. 3 problems, guys. You can do that. You can do that and do a little bit more work on a missing assignment that you haven't turned in, okay? So we will finish this up tomorrow. Friday, you will be reviewing. I will not be here on Friday. So you will get a review worksheet. You're going to work on it as much as you can. Work on it a little bit over the weekend. Come in with your questions on Monday, and your test will be Tuesday. Okay? All right.